Tires are often called the soul of motion, the unsung heroes beneath every vehicle, silently gripping the road and carrying us forward. In the United States alone, more than 280 million vehicles roam the highways, freeways, deserts, and back roads of a vast country built on movement. Every mile driven depends on those 4 rings of engineered rubber, and around the world, annual tire production has skyrocketed to over 5 billion units, a number greater than the entire population of the United States by a factor of nearly 8. But have you ever wondered how a tire, starting as a milky white latex drip from tropical rubber plantations, becomes the high-performance component that keeps a 1,000 horsepower race car glued to the pavement during a high-speed corner? Each tire is an engineering symphony, dozens of layers, thousands of chemical interactions, and millions of microscopic fibers, all bonded to survive heat, pressure, friction, and time. Whether you're driving a 700 horsepower American muscle car, a heavy-duty pickup hauling tons across state lines, or a family SUV navigating winter roads in Minnesota, one thing is certain: without good tires, all the power in the world means nothing. If this journey opened your eyes to the hidden world behind everyday life, hit the like button, subscribe, and share this video. Your support helps us keep exploring the science, the engineering, and the stories that move our world forward. Today, we take you deep inside the incredible journey of the modern tire, an industrial marvel often overlooked despite its immense importance. From raw materials to high-tech simulations, from robotic assembly to extreme quality testing, you are about to witness the unseen world behind this everyday essential. A tire may be only a thin layer of rubber connecting vehicles to asphalt, but it determines everything: cornering, braking, stability, safety, and performance. Behind that seemingly simple ring of rubber lies a global industry operating in over 180 countries, with thousands of factories working around the clock to support a worldwide fleet of nearly 1.5 billion vehicles. The tire industry alone is valued at more than $320 billion, driving demand for natural rubber, steel, textiles, and advanced recycled materials. On the racetrack, a Formula One tire may last just 50 to 100 kilometers. Some barely survive a few aggressive laps before they must be replaced. A good tire can mean the difference between victory and disaster, between a smooth launch and a catastrophic slide. And beyond the racetrack, old tires are finding a second life in playgrounds, construction materials, sound insulation products, and even as part of new tires. Proof that their journey doesn't end once the road does. But before a tire ever touches the highway, its story begins far away, under the canopy of tropical forests, where the Hevea brasiliensis tree slowly releases the latex that started it all. Long before the first revolution of a wheel, the making of a tire begins with a fragile, milky white liquid, natural latex. Deep in rubber plantations across tropical regions, such as Southeast Asia and parts of Central America, skilled workers carefully slice into the bark of the rubber tree. Each incision must be precise, deep enough to reach the latex channels, yet shallow enough to avoid damaging the tree's vital inner layers. A mistake could kill a tree in weeks. Drop by drop, latex collects into small containers. It is mixed with ammonia to prevent coagulation, then transported to processing facilities where it is concentrated, rolled, and dried into sheets of natural rubber. But natural rubber alone is not enough to create a modern tire capable of withstanding high speeds, extreme temperatures, and long-distance endurance. To enhance performance, natural rubber is blended with synthetic rubber, a highly engineered material developed through petrochemical processes in American factories and laboratories. Unlike natural latex, synthetic rubber is created by polymerizing molecules such as butadiene, styrene, and isoprene, chemicals derived from petroleum and natural gas. The result is a tough, flexible polymer that maintains stability under intense stress. More than 60% of a modern tire is made from synthetic rubber, giving it durability, cold weather tolerance, and resistance to wear. And yet, the most iconic visual characteristic of a tire, the deep, rich black color, isn't natural at all. Raw rubber is pale and soft. To transform it into something capable of supporting a 5,000-pound truck barreling down an interstate at 70 miles per hour, manufacturers combine more than 30 components in an industrial mixing process that resembles chemical alchemy. Among the key elements, carbon black strengthens the rubber and protects it from UV radiation. Silica boosts traction and efficiency. Oils and softeners maintain elasticity. Sulfur enables vulcanization, the curing process. Specialized additives fine-tune hardness, heat resistance, rolling performance, and noise reduction. Massive industrial mixers knead the ingredients under intense pressure and heat. In minutes, the mixture transforms into a thick, jet-black rubber compound. Though it looks simple, this compound contains a highly engineered network of molecular bonds that give tires their remarkable endurance. The mixed rubber is flattened into sheets, rolled, cooled, and prepared for the next stage of assembly. A tire is not just rubber. It is a multi-layered structure built from precision-crafted materials. Inner liner, the airtight layer that holds pressure. Body plies, sheets of rubber-coated synthetic fabric that form the tire's skeleton. Steel belts, ultra-strong wires aligned in perfect parallel to stabilize the tread. Bead bundles, thick steel cables that anchor the tire to the rim. Tread compound, the rugged outer surface that grips the pavement. Through calendaring machines, heated rollers applying pressure, rubber is bonded to fabrics and steel cords, forming reinforced layers capable of withstanding extraordinary forces. Every component must be flawless. Even a tiny bubble or wrinkle can compromise safety. When the layers are ready, assembly begins on a large, rotating metal drum. Robotic arms place each layer with millimetric precision, guided by sensors and computer systems. Every layer must align perfectly. Tolerances in tire manufacturing can be as tight as 0.1 millimeter. High-speed cameras scan the surface, instantly correcting misalignments. Once the basic green tire is built, it is inflated slightly, so the layers press together, forming a uniform structure. Then comes the moment of transformation. The assembled tire enters a mold, two massive metal halves carved with the exact pattern of the final tread. Inside the mold, a bladder inflates with superheated air or steam, pressing the tire outward against the mold walls. At temperatures between 160 and 180 degrees C, 320, 356 degree F, the rubber cures as sulfur atoms form crosslinks between polymer chains. This process, vulcanization, turns soft rubber into a resilient, elastic, enduring material. In 10 to 15 minutes, the tread pattern is imprinted, the sidewalls are shaped, and the tire acquires its final identity. A few moments later, the mold opens, and a tire is born. A tire may look finished, but it must survive a gauntlet of rigorous tests. Laser geometry scans, ensuring perfect roundness, symmetry, and balance. High-pressure inflation tests, detecting leaks, bulges, or structural weaknesses. X-ray inspection, revealing internal misalignments or hidden defects invisible to the human eye. Only the tires that meet every strict standard earn approval. Those that fail are recycled or destroyed. In the US, hundreds of millions of tires reach the end of their lifespan each year. Tires do not biodegrade. and can release toxic chemicals if burned improperly. That's why modern recycling technologies are crucial. Used tires are shredded into granules, heated, pressurized, and chemically treated to restore elasticity. Recycled rubber is used in playground surfaces, running tracks, acoustic insulation construction materials, asphalt blends for quieter highways, and even as part of new tire layers. Up to 20% of a new tire can be made from recycled material. It's a step toward a more sustainable, circular future. Behind every journey, every road trip, delivery truck, rescue mission, race car, or daily commute, there is a tire absorbing shocks, gripping pavement, and silently doing its job. It may seem like nothing more than a ring of rubber, but everything begins and ends with those few square inches touching the ground. Our safety, our mobility, our modern way of life, all depend on the tire.
If you found this exploration fascinating, feel free to like, comment, and share with anyone curious about how the world truly works behind the scenes. Curiosity drives innovation. If you enjoyed uncovering the story behind the modern tire, make sure to like, comment, and subscribe. Join us as we continue exploring the technologies shaping the future of our world.